Solving systems of equations by graphing, chapter 52. The method of solving a system of two equations and two unknowns graphically with pencil and paper is useful when verifying the reasonableness of a solution. Using this method is not recommended for solving a system of two equations and two variables, in two unknowns, variables, with pencil and paper if the solution has decimals. The method is useful in approximating a solution with a graphing calculator. In this case, you may have to solve each equation for one variable x in terms of the other, which is y. So solve for y in terms of x. As an example, solve y, which is x minus 5, and the second equation, the second line, if you graph it, y is negative 2x plus 1. Like we did before in graphing, we find 2 points, like the intercepts, the a for the y-intercept for one line, the c for the y-intercept of the other line, another point b on one line, another point d on one line. They seem to intersect in the neighborhood of 2, negative 3. Okay. In order to find the y-intercept, you replace x by 0. In order to find the y, which is negative 1, you replace x by a number like 4. These numbers are not unique. You can pick any numbers you want to, but make it easy on yourself. Let x be 0. Then y is immediate. So you have your two equations, and as I said, it looks like they intersect at 2, negative 3. About these two equations, you draw the lines, you have them look like the lines are parallel. They may or may not be. In this case they are because the slopes are the same. The slope is equal to 1 for one line, the slope is equal to 1 for the other line. Y is mx plus b. Only the b varies in this example. So where do the lines intersect? They don't intersect. There's no solution. There is no point with coordinates x and y which will solve both equations at the same time. So no solution. What about y, which is pi x plus 1, and y, which is 3.14 plus 1? You graph them, they certainly look like they're parallel. Are they parallel? No, they are not. Because one slope is pi and one slope is 3.14. Now when they teach you use 3.14 in place of pi, that's an approximation. But pi is really an irrational number. There are infinitely many decimals. There's no pattern that repeats itself. So pi is in reality 3.14159 and so on, which is not the same as exactly 3.14. These two lines will meet eventually. They'll meet way, way up there in the clouds, but they will meet. So are the lines parallel? No. Graphically, you don't see that. Okay, so there is no solution. There is a solution in this particular case, yes. What is it? Well, be my guest. Solve for it. How about this one? Well, if you multiply the first one by 2, you get the second one. So the second equation refers to the same line as the first equation. You draw one line, you draw the other line. They are one on top of each other. Any point that is a solution of one equation is also a solution of the other equation. Any point that is on one line is also on the other line, because the other line is the first line. So how many solutions are there? Infinitely many. Pick your birthday, plug in your birthday for x, solve for y, you have a point. Plug in your father's birthday, the day, not the year, doesn't matter. And you get a point on the line. Okay? You use x as your father's birthday, you solve for y, you got a point on the line. I am saying there are infinitely many solutions. What I'm not saying is pick x arbitrarily and pick y arbitrarily. You can pick one of those two arbitrarily, like x, but y will have to follow what x is. Okay, exercises.